Welcome to Advent of Code 2016. This is day 24. Let's get started. Air duct spelunking. Die Hard. All right. HVAC, okay. Blueprint, 0 is your current location. All right, in no particular order, the robot needs to visit each of these at least once. Walls, open passages. All right. Robots not very fast need to find the shortest route. Get your puzzle input. Interesting. Very interesting. Okay, so this is some kind of maze type thing. Fewest number of steps required to visit every non-zero number marked on the map at least once. All right. Okay. So my first thought is a good old breadth first search. So let's pull this code out. And then we would need some kind of valid moves. In some kind of state. And then I guess that we would recognize that a state was final in some other way. All right, so I think I might represent a state as something like it's going to be actually let's do this. Let's define ducts. All right. Let's see, what would be a good data structure for this? Probably something like this, where parse is defined for some string as, let's see, we want to say basically map and a function where and we want to represent it as closed, otherwise open. Yeah, that sounds good. So if we tried to parse the first of clipboard lines, it is the first of clipboard lines here. First of clipboard lines is this. Oh, right. Like I forget every time. I got to reevaluate parse like this. All right, that looks pretty good. Let's make it a map V so that it's associative. All right, and then let's define our ducts by this here. This shouldn't be too big. Yeah. All right, and then the count of the first. All right, that's a pretty regular type grid. Actually, I can even do I could get the frequencies of map count to ducts. All right, very good. All right, definitely it's a grid. Okay, and then our starting state, I'm going to represent as position 0, 0. And then what is it that we have to do? We have to get some of the exposed wires in no particular order. I'll just say goals is going to be some kind of set. Here, it's just going to be an empty set. Okay. So the valid moves in a given state. Right. So for direction in 0, 1, 0, -1, 1, 0, -1, 0. And then we want to say something like, let new position be map B plus 2 from the position of state to the direction. And then we want to say, when get in ducts new position is open. Then okay, that looks pretty good. Then I guess what we would like to do is emit a situation where the position is the new position. And then actually we need to update goals also. So goals is going to be conj the goals of state to goals like this. If let goal, something like this, then I can do that. Otherwise, blah, blah, blah. Yeah, this might be okay. So actually, something like this, where this makes sense. Yeah, I guess this isn't so horrible. Let's take a look at this real quick. Take a look at it in Vim. All right, so how do we run and represent this? Let's see. So I think we can change this to when not equal closed. And then we're also going to let our dest be something like this here. All right. Then we need to map via cond, some kind of cond. If the thing is this, then say that it's closed. If the thing is this, we say that it's open. And else, we're going to do, does read string work on things like that? Okay. But I presume that'll work. Of this thing, get to S. Okay. So redefine that. Copy this to our clipboard and redefine ducts. And somewhere in here, we should start to see some numbers. Might be kind of hard to find among all the keywords, but let's see, where's the first one of these? Looks like it's in the first line, so in here somewhere. Number 2? No number 2s. All right. All right, we want to make sure that we've got the right data structure here. So what are the frequencies of the second of ducks? All right, there's the number 2. Okay, very good. All right, so here we go. So we got our dest out here. Very good. Checking that it isn't closed. All right, then we want to say something like, if let, let's see, can we do map frequencies to ducks? Apply merge with plus. Looks like we got 7, 1, 4, 6. So what are these keys? And also, can I sort them? I mean, I can't sort them. All right. So goals are the numbers 1 through 7. So apply is set to our dest. And then that. All right, that looks pretty good. Then we know that a state of is final if the count of the goals in a state is 8. Okay, pretty good. Pretty good. All right, so let's change ducks to def once because we don't need to redefine it. We don't want to redefine it with the state of our clipboard. Run this whole thing. All right, saying that one of my for loops doesn't look good. This looks good. Let's see, 67. It's saying that no, it's saying this doesn't look good. So let's see. I have a let in here. Ah, right. Yeah. Okay, this needs to be a keyword blend. Okay, then it doesn't like the if let. Right, so this should be go like this. Okay, that looks pretty good. All this, and then something like BFS starting state. Run in my handy thing here. All right, lots of exploration, which I guess is not that surprising, given that, well, so I think we can check the progress since we have this inspector here by saying something like, give me the max key by count goals of a count of goals of the val of this in M. Oh my goodness. Position being negative, that is not a good sign. All right. So I think that the problem, one of the problems here, is that you actually start at 1, 1. So let's try starting at 1, 1. Yeah, that sounds good. Actually, let's double check the following. So, all right, map play the following, to reach the following, to reach every non-zero. Okay, so actually, so the 0 is where you start at. So where is the 0 at? I see. Let's double check the problem statement here. 0 is your current location. Very good, very good, very good. All right, so if we're looking at this, like this here. I was looking for 0 and setting a line number. All right, so this is actually 17, 0, 1, 2, 3. All right, so this is 17, 3. Oh, hang on, actually, it's XY, 17. That is, well, now let's double check it now, because the way we're parsing it is each of the lines. So get in. So the first thing that we're getting in is the line. So it is 17.3. And then our end state is actually this. Reload the starting state, reload final. Run our breadth first search again. And then where is our, all right, we got an answer, 440. Not the right answer, it was too low. I think I have an idea about why it was too low. And that's because we need to take this out. Try running it again. All right, new answer, 498. Sounds a little bit better. And then since we have a little bit of time, 30 seconds or so, what we can do is, so I think that the state M is going to be, so if we can apply max key based on the count of goals of the key of this thing in M. 2, 3, 4, 5, 6, 7. 498. Right answer, rank 17. Pretty good. All right. You notice? All right. Someone's bound to notice. What's the fewest number of steps required to start at 0, visit every non-zero number marked on the map at least once, and then return to 0? Very interesting. So that is not necessarily the same as just do everything and then return to 0. So I think what we have to do is we have to explore what are all of the ways to reach 6 nodes and then return to 0. So I think we might do something like this. We might have something like latest. And then we'll say we will define latest to be this dest here. And then I think we'll define a final state to be makes sense. By itself, this doesn't make sense, but I think this is the right approach. And then let's see. So if we do this, this is looking for a state where we get to the end. All right, I don't want to let this run for too long. But basically, I'm thinking that we'll run this for numbers 1 through 7, and then we'll separately calculate. Okay, so 1, something like 1, 776. And then we'll separately calculate how long it takes to get to each of these numbers. So 2 is 502. is 520. Running 3, 4, 5, 6, and 7. Six. Oh, hang on. Nope. That should be 4. 4 is 736. 5. Eight. Seems unlikely that it's going to be that we have to go to 6 and then go back home, but for the sake of completeness, 734, and then so I guess in a way, I am kind of like implementing an A star. So, all right, so the first thing that I want to check is basically, so I need to find out where 5 is, and then I need to do a breadth first search based on, so def starting state to be something like this. So this is wherever the 5 is, and then I'm going to need to change goals to one that now includes goals, but then my definition of final is going to be changing to I'll just do it like this. Equals 1 count goals in state. Definition of final changed. Definition of valid move changed. Our starting state, so we've got to load it up with wherever the 5 is. I think I have my Vim here. Where's 5 at? Oh boy, how am I supposed to do this? Well, this is 100 across. Where can I get? How can Vim tell me? What if I just do Vim horizontal position? Help scroll navigation. No, that's not really whatever. Eyeballing this, it looks like somewhere around 80. No, not even close. This is actually probably somewhere around 170. Yep. All right. Let's try 168. Okay, not quite right. 167. All right. So let's see. If I start at 0 and then had to move 167 to the right, then that means I'm on line 35 and 167. Okay. This is saying 304. Yeah. Oh wow. Yeah. A 314. Yeah, something like A star would definitely be helpful here because you can see that I already have to. All right. So then maybe now what I need to do. All right. Let's bring the computer into this. Okay. So we're going to say something like you seek like KV in these values here. So uncomment all of these and then bring these up. So let's put these in a data structure. This. Line it up nice. Okay, and then I think I want to say something like, I want to like redefine my starting state. It's pretty ugly, but I think, what is the best way to find this thing in here? All right, what happens if I say, no, this is fine. This. Something like locate indux k, something like that. Actually, I'll just do locate since dux is defined here. For some k character, we want to say for y value in range count dux, for x value in range count first of dux, and get in dux yx is equal to that k, then emit, is it xy or yx? I think it's yx. I think that's the system that I've chosen here. All right, therefore, if I say locate 5, like I did before, the answer is I can't find it. All right. Oh, is it locate like this? 5? Yeah, it is. Okay, so I put all this work into identifying characters for nothing. Okay. All right. Okay, so then I redefine my starting location to be this thing. Then I run a breadth first search, starting with starting state like this. Let the distance be this. Then I PRN, I guess something like K list. Does this look good? Maybe. Persistent vector can't be cast to a number. To seek, okay, what's going on here? So I'm right, redefine starting state, that should be fine. Numbers add. I don't like the look of that. Locate is wrong. This needs to be a first. Okay. Yeah, and I also need to make this more quiet. Let's go into my BFS. I'm just going to have to assume that this is correct. Redefine BFS. Get myself into this namespace. Run this thing. All right. Okay, so these are the numbers that I have to add to my other numbers. Excuse me. And did I get rid of them? All that effort I put into getting those numbers? Okay, then, all right, then why don't I just do this? FN, just do what I did before. Yeah, reader-based languages can be helpful. So we say equals K this, and then we do this. Okay. Oh, and then we also have to redefine what final is. Yeah, this is really ugly, but it might work. Redefine final, and then how did I do it up here? Ugh, this is so ugly. Why did I get rid of the code? Why did I get rid of my results? All right, so maybe I shouldn't do this. Instead, let me just okay. So I have these results, which I'm not going to get rid of. Let me go down here. Okay. Then do I just need to run them again? 80? We got over here. Ugh, terrible, terrible. That might be the fastest though. All right, so let's change this to goals being 1, 2, 3, 4, 5, 6, 7 for valid moves, and goals like this. And then let's take a look here. All right, so let's start with 1. Let's see. Nope, actually, this, and then let's see. Let's try redefining it. Locate 0. And then define final to be such that it ends at K. Ugh. All right, so this seems to be saying 2, 48, 98. But this isn't right. All right, so for each of these values, what I'm going to do, first of all, is calculate. Okay, so already this is just wrong because I need to redef my starting state here. So what I'm doing here is I'm redefining how long it's going to take to get to a certain state. Then I need to redefine what it means to be final, like this here, and I say like this, and then also I also have to redefine starting valid moves. Oh boy, this is pretty bad, but I think it'll work. All right, take this, indent. All right, so in this situation, we only care about that. All right. But in the other situation, we care about, that's starting to locate 0. Yep. And then the other situation, we care about 1, 2, 3, 4, 5, 6, 7. All right. All right. Yeah, pretty ugly, but let's see what happens. It says 498, 2, 2. Not right. Not right. We have to, did we not redefine our starting state? Correct, we did not. This needs to be locate. This needs to be locate K. And what do we end up with? Keep getting these 498s. I think, did we define final properly? Oh yeah, no, we did not define final properly. Oh no, we did. I'm sorry that this seems to be saying that the fastest way to get to anything, to end on anything is 498. But I'm going to trust it for now. I really don't trust it. So equals 7, the counter thing. K is the latest of the things. Okay, so that's correct. Then our starting state, correct. Okay, then valid moves. Okay. Then okay, this looks good. Oh, this is wrong. Final in the second case is just going to be that we have a goal. Still all these 498s. I guess if it was all a big circle, and then it wouldn't matter what our fastest way of getting there was. All right, well, let's try it. Let's just add 498 to 28, giving us 526, and see if it gives us the right answer. Not the right answer, too low. Oh, we screwed something up here. We might have to just back up and define it in a more structured way, aside from this sort of nonsense that we have going on here. On the other hand, let's see why this doesn't work. Happens if we map locate 0, 1 to range 8. So that's right. Yeah. Okay. Oh, we did have these things in here. Oh, so we can calculate it. All right. Anybody that was complaining about this before, all right, I found it. I found our original numbers. So I basically have to just map plus to 8, 310, 304, 88, 314, 70, 292, 6, 2, 520, 736, 498, 734, 528. All right. Sort these numbers. 804. Right answer, rank 70. All right, very nice, very nice. All right, let's go over the problem here. Okay, so what we have is a big map here. Let me see if I can zoom out a little bit. Okay, and then what this is basically saying is that there are a bunch of numbers here, and your goal is to travel around the ducks and collect as many of these numbers as you can. Collect all of them, and then you're done. So the robot is moving along, and it's collecting these numbers. So this looks a more maybe it has a broader search tree than it actually does. But in fact, since most of the time you're just crawling along the ducks anyway, and we're not going to repeat any search states, then it turns out to be pretty tractable. So I just incorporated my breadth first search from a previous problem, and then everything just worked out, and I got the right answer. Then in step 2, the situation was that you have to return to where you started, and in that situation, I just sort of did a brute force kind of approach, where for each of the best way to get back where you started is to consider all the numbers 1 through 7, and then first you got to get there, then you have to figure out how much it costs you to get back, and I was fiddling around for a little while trying to get both numbers at the same time, but I actually computed both numbers separately, and I had lost the numbers for a second. I was so deep into the program, but then what I ended up doing is I found both numbers at the same time, and then I was just able to do one of these, and then this ended up giving me the correct answer here. So let's take a look at a quick look at the leaderboard here. Only one day to go, so all right, 58th place, and only 1 point behind the 57th point player, and plenty of room to grow. Plenty of room. I mean, so I can gain at most 200 points, and even that is probably pretty unlikely. All right, so it looks like I'm going to finish in somewhere in the 40s, 50s, or 60s. Let's take a look at our advent calendar. All right, yeah, we can see here the Christmas tree on the side of this building. Things looking great, very festive in this city here, and I cannot wait to see tomorrow's problem. So I hope you'll join me for that, and I hope you enjoyed tonight's video. Thanks for watching.